Hey, what's up, guys? I am going to go through the book, starting out with Java Early Objects, 5th edition, by Tony Gaddis. I'm going to go through the programming challenges. We're going to skip the first chapter because it's just like print out Hello World, but we're going to go to the second chapter, which is Java Fundamentals. I think it's a lot about variables and stuff. I'm using IntelliJ. I'm gonna get into that later, just like why I'm using IntelliJ. For now, if you're just getting started, that's not gonna be as important as knowing the syntax. So if you're just starting, if you're just in the beginning of a Java course, I would use Dr. Java. But anyways, IntelliJ is nice because it has a lot of features. Anyway, so what I like to do is when I create a new when I start a new project is just have the name of the project and then I have a package. So the package, this one is Program Challenge 1. It's called Name, Age, and Income. Then I'd like to take it from the textbook, copy the instructions, and I have this spot here that I paste it in. So when I'm doing it, I have the instructions right there, so I have the screen full. And also, it's nice that if I'm gonna be handing it in, because I took this course in Intro to Java in January of 2018. Right now it's December, so I'm on my third course in Java. So I'm still a beginner too. So this is just as much for me as it is for anybody else who's taking these classes and maybe needs some help or just wants a way to cheat on their homework. No, that's not what this is for. Hopefully this is going to help you, but this is just as not as much for me as it is for anybody watching, because I feel like when you can explain something to other people, you understand it good. So anyways, okay, write a program that declares the following. Alright, so this is going to actually just be in a main program, and on IntelliJ you can just write PSVM for public static void main string array args. Now you should be able to write this in your sleep by the time you're going to be using a IDE like this. You should be able to type this all out without checking the book, without any, just off the top of your dome, the syntax. Alright, question. Write a program that declares the following: a string variable named name, an int variable named age, a double variable named annual pay. Sorry, it gets a little lost in translation. Store your age, name, and desired annual income as literals, so string literals in these variables. The program should display these variables on the screen in a manner similar to the following. My name is Joe Mahoney, my age is 26, and I hope to earn $100,000 per year. Alright, so start off, it says a string variable, so we'll do a string variable named name, okay, an int variable named age, and a double variable named annual pay. This is in camel case. Store your name, age, and income as literals in these variables. Alright, so that means that as literals meaning set them or initialize them. Initialize isn't the word. When I think of a literal, I think of a string literal, as in Jeff Zoref. That's a string literal. Okay? I guess they mean literal for age too, so 36. And then annual pay. Well, yeah, $100,000 would be nice. 100,000. All right, so print them out. So we're gonna do so we can just do s out, but it's system.out.println. All right, so it'll say my this is the string literal part, name is, and then we're going to, I could write Jeffrey Zorev, but that's not what they want. They want us to use the name variable. So what we're going to do is, using the plus sign, that's called concatenation. We're going to concatenate the variable inside of the print line constructor. Alright, and my name is name, and my and then we're going to have a space here too, because if there was no space at the end there or the beginning, it would all come together. There would be no spaces. My age is age, okay, and I hope to earn annual pay. Alright, and then we're gonna run it, and okay. And we can also, so we can also put a period just so it looks exactly like that. If that's what your professor's about, we can write it exactly like that with a period. And then what we can also do is have it so that since they want a line after and, what we can do is use what's called my age is, so, and so we can use what's called an escape character. It's a backslash and an end for a new line. So escape characters, they're in the book. So as you can see, I didn't put a space between the variable, so that's why there's a space. My name is Jeff Zorev. My age is 36, and I hope to earn 100,000. And then we can just say here, $100,000. Okay, let's move on to this next one, name and initials. Alright, so I'm just going to copy it. What I'm going to just do is come into here, I'm going to go to source file, package, and then do PC2. And I'm going to create a new Java class. This one's going to be called name and initials. So we have camel case, and the way that it typically is, you don't have to do it this way, but class names have a capital letter. Method names, we'll get to that later, have lowercase letters to begin with. And variables have lowercase letters to begin with too. And then each new word is a camel case, is an uppercase. Alright, let's just get this right. Name and initials. Right, here we can just put this to the side. Alright, right. Okay, fine. So, write a program that has the following string variable, first name, middle name, and last name. Initialize these with your first, middle, and last. The program should the following character variables, first initial, store the initials, and then display the contents of the variables on the screen. Alright, same thing, basically. Now, so we'll do string first name, sorry, string literals, strings have to be in double quotes. String, stack trace, string, middle name. What's nice with, is Hillard actually. What's nice with, string last name, with typing, IntelliType or text complete, is that you can write out longer, more descriptive variable names and not have to worry about typing them the same every time because it automatically types it for you. So now we have character for first initial. You know, if you're doing this in TextPad, you have to write it out again. So character variables don't have double quotes, they have single quotes, right? So, and actually what we can just do is copy it and paste it and just change this here. I think myself and I think I've heard, real, professional programmers, they always are looking for ways to make their, people say, programmers are lazy. Yeah, it's true. We're always looking for quicker, easier ways to do the same thing. Working smart, not hard. Alright, store them. Okay. The program should display the contents of the variable. So we're going to do our system.out that print line again. Oh, so I forgot to add the public static void main string arg. So the class itself has one open bracket and one closing bracket, and then this main statement has an opening and closing. So you have two brackets at the bottom. For every opening bracket, there must be a closing bracket. Okay. All right. So let's print out. We could just do it however we want. We'll just do this. First name plus, and then we're going to need a space in between, right? Plus, and then what I'm going to just do is copy this because I'm going to be using this. So for space, first name, middle name, need a and last name. Oh, I did that in uppercase for some reason. Like I said, and it doesn't have to. Oh, so and then I hit Control Alt L just to clean it up. That's just an IntelliJ thing. So, and then what we can do is do a new a new line using our escape character. And there's other escape characters, like for example, T is a tab over, and there's more. They're in the book. Okay, so then we have first initial, middle. Oops. Oh, I did that uppercase as well. Dumb. Middle and last. Okay, just out of habit for some reason. I don't know why. Middle initial and last initial. Alright, so let's print that out. Okay. Alright, we could have put periods, or we could actually just do this. Not here. So, if you want to put periods, put a period. Put a period here and here. Wait. Yeah. Okay. Next. Personal info. Write a program that displays the following info on a separate line. Alright. This is the same idea, okay? You're just doing your name, your address, your city. Okay. Star program. We want a program that displays the following star pattern. Alright, well, now later on, of course, there'll be, not of course, but later on there'll be you'll find throughout the book that there's a lot of the programming challenges are the same, except you just need to apply what you just learned in the new chapter. So later on, you actually use more complicated means to print out stars using. Now, let me see if I can just. You know what? It doesn't really matter. I'm not gonna. Hold on, this got copied over by accident. It doesn't matter. We know what it is. It's gonna be 1, 2, 3, 1, 3, 5, and then 7, and then down again. So how can we do this? There's a couple ways we can do it, but one way we can start is by doing the first and I like to, you know, the system.out.print is a way to check your work. Now I know that since the first star is in the middle, it's going to be it's going to have to be moved over. So let's try the tab escape. Okay, sure. Now what we can do is this. We can do it in the same print line statement, or we can do it in the next one. We can just do 3. And now we're going to have to probably tab those over so that it gets, and sometimes there's some finagling you got to do. Yep. So what we can do is have this over 1 and just move it like that. Actually, it might be that, oh, I see. Yeah, it might actually just be that I have to move this over. There we go. Okay. And then, same thing. Oops. Always remember to do double quotes. Now we got 5. We could also do this in one line using the / and escape character. Alright, so we're going to have to move this over. Alright, and then I think we're on our way. Let's copy this. And actually we're going to have to probably move it over. And then this is going to be 7. So we're testing as we go along, you see. Alright, cool. And then we're going to use this one again, right? Because it's going to be the same. 5, and then 3, and then 1. Again, you could write this all in one line using the and escape character, but this is the easiest way to do it. Alright, cookie calories. A bag of cookies holds 40 cookies. The calorie information in the bag claims that there are 10 servings in the bag and that a serving equals 300 calories. Write a program lets the user enter the number of cookies he or she ate and then report the number of calories consumed. Alright, so this is the first programming challenge that's going to be using this, that's going to be taking in user information. And the way that we take in user information is through the scanner. Okay. Now, what I have here is, hold on. What I have, what's this one called? Cookie calorie. We're calling it PC. I would just, yeah, I like to have, I don't know why I call that PC4. I like to have I like to have the same system. So cookie calories, gotta be one word, right? Alright, so did I copy that? Yeah, okay. So I have what's nice about IntelliJ is you can create your own automated text so that the scanner shows up automatically, but let me just write it out for you. So the scanner needs to be the scanner is part of the util class. It's an API, which is a library. You might learn more about that in later chapters, but it's going to be util.scanner. Okay? The scanner takes in input from the keyboard, and now what we need to do is create an instance of the scanner class, because scanner is a class. I like to call it input. You can call it SC, you can call it keyboard, whatever you want. And it equals new scanner. New scanner. And the source is system.in. That's just it from the keyboard. It's coming in, not out. Out is something else, file reading, but that's later. Alright, so now we have our scanner. Now we say a a bag of cookies holds. So when I start a question where I know I'll need user input, what I like to do before I write anything is I like to think, what question will the user get asked? Well, the user's going to be asked, again, let's put PSVM, okay, forget, okay, so the user's going to be asked the number of cookies they ate, okay, so how many cookies did you eat? Okay. Now, the way that you take that information is you create an whatever is appropriate, what variable type, integer, string, double. Well, we're gonna say that we're eating one, whole cookie, so we're gonna have an integer, and we'll call that user cookies. I like having user in the beginning of my of what I use to hold in as a scanner class. So the syntax is then the variable that's going to hold what the user put. Then it's whatever you call the scanner. I call my input dot next and then int. If it was a double, it'd be next double. If it was a string, it'd be next or next line. Okay, that's the syntax. Now, if I run this, here's what's going to happen. I'll say, how many cookies do you eat? I'll say 4. That's it. Nothing happens. But it did take it in. It did take my user input in. But we need to do something with it. What we need to do is say that say how many calories. So how many calories per cookie? Well, there's 40 cookies, 10 servings. One serving then is 4 cookies, and each serving is 300 calories. So it's going to be, since one serving is 4 cookies and one serving of calories is 300, it's going to be 4 times 300. That's 1,200, right? Let's just make sure. I'm terrible at math, but it's 4 times 300, so 1,200. All right. So what we can do then is say we can create an integer to hold because what we want to report is the number of calories consumed. So let's create an integer variable called well, actually what we can do is up at the top usually is where you want to put your variable declarations, unless they're instance variables. Instance variables are when you declare your variable at the time of use. Field variables are variables you write at the top that you're going to need later. So let's do that, and this is going to actually be a final. A final is a constant number. The constant is 300 calories. Now, so we're going to say it's a final integer, and then by standard Java practice is that all final numbers or constants are capitalized all throughout, and then if there's a space, you put an underspace cookies. But we're not going to do that. Calories equals 300. That means that since it's final, that it can never be. It's not that it can never be changed up here, but once it's down here, you can't use calories in an equation in a way that's going to change the value of calories, because calories will always be 300. Okay? User cookies, now that's a variable that's going to change all over the place. Okay? So anyways, so we want to find out calories consumed. All right? So the calories consumed is simply number of cookies eaten times 300, or times and the reason that I didn't say, so let me just show you. So I'm going to create an integer called user calories, okay? And now I'm going to set user calories. It's just going to equal user cookies, however many cookies the user ate, multiplied by calories. Now the reason I didn't say, I could just as easily say 300. No difference, right? We still get the same answer. It's called a magic number. If you have a huge long project with multiple classes and you got 300 there, you're like, wait, okay, so why 300? You know, I've seen it happen. Seen it happen to me. Well, if you have it up here, and you see calories being used all over the place, you can be like, okay, calories, that's 300. Or what if what if new information comes in and the calories per serving is actually 400? They mismeasured. Do you want to go throughout the entire 500 line program changing 300? Every instance of 300? No. Change it once up here. That's why we do that, okay? It might not make a lot of sense to do that on a small program, but believe me, you're gonna be glad that you have this habit down now, okay? Anyways, now we need to get the answer out. We're gonna ask the person, because it says here, it says, write the program that lets them enter the number of cookies they ate and report the calories consumed. So now we need to report something. We're going to report the calories consumed. So we can say you ate. We can do this any way we want. We can just have calories. Like if I did this, user calories. Because that holds the answer. I could just print that out and say, how many? 4. Okay, 1200. Well, that's cool, but that doesn't tell us much. So let's actually add some information here. You consumed how many cookies? You can say user cookies, because we don't know how many user cookies, because we don't know how many cookies the person ate until they write it. So you consumed user cookies, and then we can say here, which is user calories. We don't know how many calories. User calories. Calories. Okay, let's see how that looks. You consumed 4. Well, okay. 4 what? 4 cookies. See, this is why testing is why you're testing it, okay? Put a period at the end there. Let's say 87. You consumed 87, okay, another thing, which is 26,000 calories. Okay, you consumed 23 cookies. You consumed 23 cookies, which is 6,900 calories. Okay? Alright, next. Sales prediction. Okay. Let's copy it. Come on. Okay. Alright. PC 6, and that's going to be sales prediction. Whoop, no spaces. Alright, so let's put the question here, Control L, sales prediction. Also this up here, that's live template. I can show you what that is later if anybody's interested. Sales prediction. Okay, the East Coast Sales Division, the company, generates 65% of total sales. Based on that percentage, write a program that will predict how much the East Coast Division will generate if the company has $83 million in sales. Alright, so hint, use the value 0.65%, 65%. Yes, okay. So, it wants to generate 65% of total sales. Okay, the East Coast does. Based on that percentage, write program that will predict how much the East Coast division will generate if the company has $8.3 million in sales. Alright, well, if the company generates $8.3 million in sales, the East Coast represents 65%. So, you know, the East Coast will represent 65% of 8.3 million, which I don't know what that is, but I do know that to find it, we'll multiply 8.3 million by 0.65, and that will give us the percentage of, right? Percentage of is just multiplying. So let's create our let's create a variable, but it's going to be a double this time. Doubles are floating point numbers, which is to say they have you know, they're fractions. They're real numbers. They have a decimal. All right, so double sales. Okay. And that right now that's going to equal 8.3 million. So that's 8,300,000. Right? Wait, 300,000. Yep, 8,300,000. And then 65% is our percentage of sales. Whoops. East Coast percentage of sales. So let's say EC percent of sales. I like to use descriptive variable names, even for simple programs. There's a lot that you can read about variable naming. Variable naming, you can call this X, you can call it Y, you can call it Jumanji, I don't know, that's a stupid example. You can call whatever you want, but if they're descriptive, then anybody looking at this program knows what this is doing. You know, and that's what you want. Okay? So the percent of sales, oh, sorry, is 65%, which is 0.65. You don't need the 0 really. You can also say D, like double, but you don't need to do that. You can just do 0.65, but I like to put a 0 before it. So let's see here. We'll just create a instance variable called total. That's going to hold the total if $8.3 million in sales. Okay, if it's so the total. Actually, we can make that. We can do that better. We can say EC sales. Whoops. Sales. Okay, so the actual number. So again, if the company made $8.3 million, how much did the East Coast generate of that if they generate 65% of all sales? Okay, well, we can just say East Coast percent of sales, that's 6.65 multiplied by sales, which is 8,300,000, and then we just can return. We can make a description, but we're returning EC sales. All right, and the answer is. Oops, sorry, it's running the wrong the last program. Okay, so it's not formatted very well right now, so let's format it. So 5395. So that's 50. Wait, what is that? Hold on. 53. That doesn't make sense. 5,395,000. Yes, it does. 5,000,000. All right, but let's. So here's. I think this is in the chapter. The printf. Okay, printf is going to be formatting. Now, there's other ways you can format. You can use decimal formatter, but I like using printf. So what we can do is say to hold. EC sales, I think it's percent F holds the floating point number. Was that not right? No. Or is it D? No, it's F. Hold on. Oh, it's got to be it's got to be a string literal. Okay, so percent F is for doubles, which is weird because percent D is for integers. Yeah, it doesn't make any sense. But if we do this and then we say I think the way you do it is, so we can say if we want to put $1 in there, we can put it in between, I believe. Nope, that's wrong. I think the dollar has to go outside. Yeah, okay, but now we got all these trailing zeros, so I think what we need to do is say 2.0. No, wait, is that right? Sometimes, no, I forget. Oh, I think it's 0.2, so that there'll be commas. I'm not wrong. No, that's not how you do it either. 0.02. I think that might be. This is how you format it. I gotta check actually. Sorry, 1 second. I haven't done this in a while, so let's see here. Printf. There we go. Let's see here. So yeah, it's in this chapter, the printf. So let's see, how do we format it? It's been a minute. Precision. Okay, so yeah, there we go. 0.2. Okay, so I knew it was something like that. So that's not correct though. Hold on. Percent. Oh, the percent. Okay, it's got to go after percent. I'm sorry, guys. 0.2. Wait, do we need a comma there? There we go. Yep. So I put a comma. Period 2. That means it goes to 2 decimal places. If I put 3, it would go to 3 decimal places, but that's not how the U.S. money system works. Also, if I didn't put the comma there, it would not give me the comma where it typically goes. So this makes it a lot more readable. So we can then just say the East Coast Division generated let's see how that works. Now, the way that you would have text after that is not to do it after this with printf. It's actually here. So, generated in sales, for example. See? East Coast Division. Coast Division. Okay? Good. Next one. Land calculator. 1 acre of land is equivalent to 43,560 feet. Write a program that calculates the number of acres in a tract of land. Divide this. Okay, let's just do this then. Okay. Here we can look at it this way actually. And I accidentally put this outside of. That doesn't matter. I just like things being neat. But anyways, close all these. These are all the different packages, and this is supposed to be its own package, but it does. Here, let me just do that. Sorry, it's stupid, but PC4, and then what we can just do is put this in. That's called refactoring. That's one of the things refactoring is. All right, so the next problem is PC. Wait, did I already? PC7. Program challenge 7 called land calculation. It's called land calc. Alright. Alright, so it says land calculation, 1 acre of land is 43,560 square feet. Write a program that calculates the number of acres in a tract of land with 389,796 feet. Hint, divide the size of the tract of land by the size in an acre. Well, that's, yeah, okay, we can do that. Alright, so let's see here. We'll call these will be integers. So we can call this acre. We can actually do this as a final, though we don't need to in this case. It's proper programming is to have constants be final. So an acre is 43,560 feet. So for our land, it's land size is 389,767 square feet. And we want to find the acres. So it says here, divide the size of the tract of land by the size of an acre to get the number of acres. Okay, that's pretty actually simple. They gave us the answer. So we just need to divide the 389,767 by 43,000. All right, so we can create a instance variable called square feet land equals the size of the tract of the land, so the land size divided by acres by 43,000, right? And that will give us the answer. And in this case, I'm not going to format it with anything special. You can do that on your own, just so it looks nice. But I'm not going to do that just because we got the answer. So it's just square feet. Okay, let's run it. 8. So a tract of land with 389,767 square feet is 8 acres. Okay. Let's see. If any of these are similar, I'm just going to skip them. Okay. Ask the user to enter the amount of the purchase. The program should then compute the state and sales tax. Okay. Display the amount of the purchase. Okay. Okay. Okay, we can do this one. This is an interesting one, I guess. It's going to be number 8. So, again, these don't need to be packages. They're so small, but I don't know. I just like to have, I just like things to be organized. What was the question called? Sales tax. Alright, so none of these use methods. Interesting. Oh, I guess methods we don't get to until the next chapter. Alright, so write a program that will ask, alright, the program should display the amount of the purchase, the sales tax, so it should look like a receipt. Alright, Alright, so here's, again, like I said, I like to start by saying, what does the user need to be asked? So it will ask the user enter a number of the amount of the purchase. Enter amount of the purchase in dollars, whatever, you can word it however you want. And that's going to be, I'm going to use the term now for, we're going to be using the scanner. I'm just going to use my shortcut to get the scanner class. Whoops. And you see it's giving me an issue because I haven't imported it, so Alt Enter will just import it. But I like to call it input. Again, you can call it whatever you want. So I'm going to create an instance variable that will hold the user's information. Okay? So this is going to be the, I'll call it, you can create it as a field variable if you'd like and just use it here. It's all the same, but it's good practice to use instance variables whenever the variable is called once. Let's say as it's being called. Okay? When you can. You can't always, but when you can. So we'll call this user user amount, I guess, doesn't matter, equals input dot next. So actually it's in we're talking about dollars, so we'll use a double because it needs to be next double. Okay, it needs, because it's money. Okay, and then it says the program should compute the state. Okay, so let's do this. Let's create some finals, because the final are going to be the tax. Okay, so the sales, actually, final double sales tax. That's how you write it, a final, or that is, say, a constant. Sales tax that is 5.5%. 5.5% is 0.05, right? 0.055. And the county sales tax. So let's just copy this. This is actually state sales tax. You don't have to write your variables as long as I am, but I like to have them, especially if you're using, and this is county, especially if you're using a IDE, or you're not using a development environment that has automatic text completion. But anyways, that's set equal to 2%, which is 0.02. Alright. Okay. The program should display the amount of the purchase, the state sales tax, the county sales tax, the total sales tax, and the total of the sale. The total of the sale is the sum of the amount of purchase plus the total sales tax. Sure. Alright. So let's create a instance variable called total, and that's equal